Road Stripe Evaluator, Michigan Technological University. As automobiles continue to develop from traditional driver-reliant vehicles into autonomous and driver-assisted vehicles, they continue to rely more heavily on visible road markings. Modern vehicles use cameras, sensors, and computers to analyze the road markings to ensure safe and efficient transportation for their passengers. These markings, however, are quick to wear away from weather and degradation due to vehicle use. Increased access to vehicles through advanced technology, a strong economy, and increased population trends make this problem even worse. Degraded road markings serve as a serious safety concern to both traditional and driverless vehicles, and thus require constant maintenance. Nearly a third of all vehicular accidents in the United States were caused at least in part by poor road conditions, and faded paint markings are one of the leading contributors to these incidents. In 2018, this resulted in more than 2 million injuries and nearly 22,000 fatalities, according to the Association for the Advancement in Automotive Medicine. The Road Stripe Evaluator, designed by the Michigan Tech Senior Design Team, aims to solve these issues by providing a mechanism for early identification and detection of degraded road markings. The use of this device allows road maintenance crews to save both time and money in repainting road lines. The Road Stripe Evaluator will analyze existing markings and alert crews of which sections need attention. By automating the detection process, maintenance personnel will no longer need to spend time assessing road markings. Additionally, crews can save money on paint, as the device will indicate the exact locations where paint is needed in lieu of repainting the entire stretch of road. More importantly, however, the Road Stripe Evaluator will help to reduce the number of accidents due to poor road conditions and improve the safety of motorists. The Road Stripe Evaluator uses a TiM 270-degree LiDAR unit to measure the reflectivity of markings on a road. An intuitive software analyzes the measured reflectivity values to determine the placement of markings, and then determines the level of degradation and provides recommendations based upon a user-defined threshold. The simplistic user interface displays a visual of the markings being analyzed and displays a yes or no value if the marking meets the designated reflectivity levels. The evaluator software could be further developed to integrate GPS data that allows for continuous monitoring of reflectivity levels from a remote location. The evaluator is capable of being mounted on vehicles such as police cars to monitor and evaluate entire regions. When markings are found to be inadequate, maintenance crews can be alerted to service these locations before the conditions pose a safety risk to motorists. The Road Stripe Evaluator is capable of integrating with current maintenance equipment, simplifying the process of road striping through automation, providing a quantitative analysis of road lines, and as a result will help to lower the overall cost of road maintenance and improve motorist safety. The Road Stripe Evaluator and integrated software was designed for the national TiM 10K Challenge by a Michigan Tech Senior Design Team. Team members, as pictured from left to right, are Brian Parvin, Paul Allen, David Brashaber, Alex Kirkner, and Curtis Alessi. The team was assisted by primary faculty advisor Dr. Tony Pinar.